Hello everyone. So today we'll try to solve the problem, leetcode problem 322, coin change. It's of medium difficulty. And for this problem, we're given a coins array, which is a list of integers and an amount, which is in value as well. And what we're trying to do is we're trying to find the minimum number of coins it would take to get the amount. Please note that we can use a coin as many times as possible, so we can have 11 ones. So in that case, the output would be 11, but that wouldn't be the minimum number of coins. In this case, we can get the minimum number of coins we can get is 5, 5, and 1. So, and if we do not find a solution, we just return -1. So in our second example, if we have just a list of 2 which cannot amount to 3, or no number of 2's can amount to 3, so we just return -1. So let's take our notepad and see how we can solve this problem.
For this problem, we're trying to find out the minimum number of coins that we can get, or we can collect to get our desired amount. So in this case, we'll have 1, 5, 5, or 5, 5, 1, or 1, 1, 1, 1, 1, and so on and so forth, 11 times. And the result would be, so we're supposed to return the number, an int value of 3, because we have 3 coins at minimum for which we can get the amount of 11. So let's see how we can solve this problem. So one of the ways we can do this is a dynamic programming solution with a DFS approach, or a depth first search approach. So we have 11, then we can create a tree with, or that's what it is. So -1, -2, and -5. Remember, our array is 1, 2, and 5. So 11 minus 1 is 10, 11 minus 2 is 9, and 11 minus 5 is 6. Then we have -1, 2, 5, and so on and so forth. At the end, you'll see that here we have -5, then we subtract -1 here. This will become 1, this will become 0. But if you go subtract 5 or -2 here, we get -1 or -4. So what we can do is, if we do not get a 0 in our case, if we get a 0, we can traverse upwards and collect our numbers. So we can collect 1, 5, and 5 in our case. And in this case, we'll have 1, 5, and 5 here as well. Oh, sorry, 0, 5, 5. But if you have a negative number, we can just return a -1. So in summation, if we reach a value, if the leaf node is equal to 0, we return the length of array. Otherwise, else, we return -1. So let's try and code.
Welcome back. So let's try and code this problem out. So this problem, we'll try to create a recursive function, def, let's call it minimum coins, self, comma, coins, amount, and there you go. So if the amount is equal to 0, we just return 0. and if the amount is less than 0, we can return an infinite value, because that means we have the maximum number of coins. Float inf. Now for recursive flow, we have for coin in coins, we can parse through, say, minimum or combination can be 1 plus whatever we get from the result, because we're going recursively, so we just iterate and keep adding the number of coins. So in this case we would have min coins, and we can pass in coins and amount. And once we have coins and amount, we have to find the minimum coin. So we instantiate coins to not 0 but rather float infinity, and then minimum coins can be the minimum number of combination and min coins. So whichever number is lower, we just return that number, and then we just return min coins. Now, as you may know, this is not the optimal solution. So we might want to implement memoization while we're at it. So we have memo, and then we just, if amount in memo, we just return that amount, return memo amount, because we don't want to compute the same value again and again. And memo amount is equal to min coins. So what do you have here? So if let's say min coins, well, we can just call it min coins, is equal to self, or well, we did forget to instantiate a memo as object, and if min coins is equal to infinity, we just return -1. That's our base case, and or not base case but rather a fail case. And if not, then we just return the result, or min coins. So let's see what the result is. Okay, so we found the problem. Well, we don't want to keep returning the amount, but rather the remaining amount. So we want to subtract, so we can just do remaining amount, because we want to keep subtracting the value, and then we can just return the remaining amount. And let's see. Bravo. So there you go. All right, so let's give it a go. And submit. There you go. So hope this helps, and see you guys next time.